Hi, good morning, everybody. Since I'm not going to be in class today, I'm going to go ahead and create a video for our review today. Let's zoom in a little bit. Oh, where am I? So, um, this right here, this is just the diagram I said I was going to share with you yesterday. This has the classifications and all of the properties. That's basically all you need to know for the test. Let's go ahead and take a look at the review here. Okay, so the key is also posted at the bottom as well, so you can check your own responses. The definition and properties of a parallelogram. Okay, so you can see all of these above as well. Let's see, my pen. Give me a second. Pen's not working. Okay, got our pen working. Okay, so definition properties of parallelogram. So parallelogram, this has opposite sides parallel. Opposite sides congruent. This is just a shape that is created by the intersection of two sets of parallel lines. The properties, opposite sides parallel, opposite sides congruent. We also have the opposite angles congruent. And we also have the diagonals bisecting each other. So this is true for any parallelogram. So in drawing form, the way that you would show all of this, you would use your parallel arrows to show that your opposite sides are parallel. You would use your congruency marks to show that the opposite sides or opposite angles are congruent. You would also use your congruency marks to show that the opposite sides are congruent. So this side and this side, and this side. And then your diagonals as well. So if I draw my diagonals here, so here's one diagonal, here's the other diagonal. They bisect each other. So this diagonal gets cut into two equal pieces. So this side and this side are the same. And then this diagonal also gets cut into two equal pieces. So this side and this side are the same. And that would be all of our properties for the parallelogram. Definition properties that are unique to a rectangle. So a rectangle will have all of these properties, but then we'll have additional properties. So one of the additional properties is that all the angles are 90 degrees. Another additional property is that the diagonals are congruent. So you have all of the properties that we have from the parallelogram, but you also have all of these angles 90 degrees, and your diagonals are congruent. But remember, they're still bisected, so all of these end up being exactly the same. Okay, because they're both bisected, but they're both the same measure. So all of these end up being congruent. So these are the additional properties for our rectangle. Definition of and properties that are unique to the rhombus. So the rhombus has a couple of unique properties as well. One of the unique properties of a rhombus is that all the sides are congruent. Another property of the rhombus is that the diagonals are perpendicular. They intersect at 90 degrees. The rhombus also has another property that is not so obvious, and that is that the diagonals bisect their opposite angles. Diagonals bisect the opposite angles. So if you're looking at a rhombus, like this, okay, all of our sides are the same measure. Since it's a parallelogram, the opposite angles are congruent. So these angles are congruent, these angles are congruent. The diagonals, so this diagonal, this diagonal and this diagonal, they will cross at a 90-degree angle. Okay, all of these will be 90, by the way. If one of these are 90, then they're all 90. So the diagonals cross at a 90-degree angle. Usually you only label one of them, and that implies that they're all. Now, the last property, the diagonals bisecting opposite angles, and get rid of some of this so you can see what that looks like. Oops, got rid of a little bit too much. Okay, so if you draw your diagonals, so here's the diagonal. Let's draw it a little bit better because we have to draw our angles here. A diagonal, here's a diagonal. Then your opposite angles are bisected. So this angle is getting cut in half. So these two are congruent because it's getting cut in half. This angle, remember that this angle and this angle are the same. It is also being cut in half. So all four of these are congruent because the opposite angles are congruent and these are getting cut in half so that they're cut into two congruent pieces. That's true for the other side as well. Okay, so on this side, this one is congruent to this one because it got bisected. And then because our opposite angles are congruent, this one and this one are congruent as well. Okay, so these are unique to the rhombus. Definition and properties of a square. So a square is just everything the rhombus has and everything the rectangle has. So let's go back to the rectangle actually. So rectangle, all properties of parallelogram plus all of these. Okay, for the rhombus, all properties of parallelogram plus all of these. For the square, this is all properties of the parallelogram plus all the properties of the rhombus plus all the properties of the rectangle. Okay, so the square is just a rhombus and a rectangle. Everything that makes a rhombus and a rectangle together will make a square. Of course, they are still parallelograms, so everything that's true about a parallelogram is true about these as well. 5 ways to determine whether or not a quadrilateral is a parallelogram. Okay, so one way you can do is, let me see what this actually wants. I think we just want to test. Yeah. 5 ways to determine whether or not quadrilateral is a parallel. Actually, I don't need to go through these. If you look at the key here, 5 ways, you can show that both pair of opposite sides are parallel. You can do that using a slope. Number 2, both pairs of opposite sides are congruent. You can do that using the distance formula or the Pythagorean theorem. 3, both pairs of opposite angles are congruent. That one's a little bit harder to do, but if you're given numbers, that one, you can do that one. Number 4, diagonals bisect each other. You can do this by finding the midpoint for the diagonals. If the midpoints are the same, then your diagonals bisect. And one pair of opposite sides is parallel and congruent. This one is the one that most people don't pay attention to. If you have one side parallel, one pair of sides parallel and that same side is congruent, this is enough for you to show that you have a parallelogram. Number 6, ways to determine whether or not a parallelogram is a rectangle. 1, show that it has 4 right angles. Technically only need to show one of the right angles. And the way that you can do that is with your slopes. If your sides have opposite reciprocal slopes, then they are parallel or perpendicular. They're right angles. You can also show its diagonals are congruent. So that can be done with a distance formula or a Pythagorean theorem. Number 7, ways to determine whether or not a parallelogram is a rhombus. Show it has a pair of consecutive sides that are congruent. Okay, this would be enough to show that all the sides are congruent. So if you have a rhombus, if you have a shape, a parallelogram, and this side are congruent, this is enough to show that all the sides are congruent, which is what a rhombus is. Show its diagonals are perpendicular. Okay, that can be done with the slope. Okay, so the first one can be done with the distance. The second one can be done with the slope. So if you do the slope of the diagonals and they're perpendicular, then it is a rhombus. Okay, and then we have the practice problem. So let's take a look at the practice problems. Identify parallelogram ABCD as a parallelogram, rectangle, rhombus, or square using the given information. Okay, now this is important. We are already told that these are parallelograms. All right, we are already given this information. We know these are parallelograms. That's good. Okay, so we know that the sides are parallel. We also know that the opposite sides are congruent. And we know some other stuff as well. Okay, so letter A. Additional information, AB and AD are congruent. So AB and AD are congruent. All right, so this is enough to show that this is a rhombus, because if this is congruent to this, this is also congruent to the opposite side, and this is congruent to the opposite side. So we have all 4 sides the same, so the best we can get for this one is a rhombus. Letter B, let's check our answers as we go. I'm pretty confident with this, yeah. Letter B, AC, that's the diagonal. So AC is congruent to DB, that's the other diagonal. Okay, so we have diagonals congruent. So these diagonals are congruent. So diagonals congruent, that is a property for the rectangle. And we don't have anything else, so that's the best we can do is the rectangle. All right, AC, that's the diagonal. DB, these are perpendicular, right angle. Okay, so that's rhombus. The best we know about this is a rhombus. Let's see, AC and DB, perpendicular. So that's rhombus, but we have more information. We have AD and DC perpendicular, which means the sides create a right angle, and that's rectangle. So this is rhombus and rectangle, which is a square. So rhombus and rectangle make a square. What do we have here? We have AD, DC, perpendicular. Okay, that's just one side. One angle is 90 degrees, which means they're all 90 degrees. That's a rectangle. And that's all we know about that. What do we have here? OC. Oh Lord, my pen. OC congruent to OD. Okay, OC, remember that the diagonals are bisected, so OC and OA, oh my god, my pen is messing up, are the same, and then OD and OB are the same. If we look closely, we see that our diagonals are congruent. So this diagonal and this diagonal are congruent because these two and these two are the same. All four of these are the same. So this is a rectangle. Diagonals are congruent, that's a rectangle. Alrighty, let's check our answer. Rhombus, rectangle, rhombus, square, rectangle, rectangle. A rhombus, rectangle, rhombus, square, rectangle, rectangle. Good. Alright, now for some coordinates. Oh my goodness, my pen keeps disconnecting. Let's see if I can fix this. All right, what is the most precise name for each quadrilateral with the given vertices? Explain your answer. Okay, this is going to be a little bit tougher. Okay, so it's not even labeled. All right. Okay, so negative 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, negative 2, 6. Negative 2, 1, 2, 3, 4, 5, 6. C, 2, 0. Whoops. And then D, negative 1, negative 2. Okay, so this is our shape. Okay, first, let us show that it's a parallelogram. All right, the way that we show it's a parallelogram is by doing one side, the slope, or one pair of sides, the slope and the length the same. So the slope of AB and the length, slope of CD. So the slope of AB is rise over 1, 2/3. Slope of DC, 1, 2, 1, 2, 3, 2/3. So those are parallel. If we also show that they're congruent, then that is also that's also enough to show this parallelogram. Okay, so AB is the square root of up 2 over 3, so 2 squared plus 3 squared. Oh, sorry, that's DC. DC is the exact same thing, 2 squared plus 3 squared. So AB is equal to 4 plus 9, 15, square root of 13, sorry. DC is equal to square root of 13. Okay, so this is a parallelogram. Now that we know it's a parallelogram, so parallelogram, check. Now that we know it's a parallelogram, we want to show that if it's a rhombus or not, or we want to show if it's a rectangle or not. So let's do the rhombus. Actually, it doesn't matter what we do. I'm going to use the diagonals for both of these. So first I'm going to use the diagonal BD. I'm going to get the length of BD and the slope of BD. Let's do slope first. So 1, 2, 3, 4, 5, 6, 7, 8, and 1. So negative 8 over 1. So negative 8. The length of BD, that would be the square root of a squared plus 1 squared. which is 65. Square root of 65. Okay, and now I'm going to compare this to the other diagonal. So the other diagonal is AC. So slope of AC. This is the easiest way I usually do for it. So let's see, A to C. So 1, 2, 3, 4. So 4. That's at 2, 0, right? Yeah, 4. So down 4. 1, 2, 3, 4, 5, 6, 7 over 7. Okay, the slopes are not opposite reciprocals. Okay, so the diagonals are not parallel or perpendicular. So this is not a rhombus, which means it's not a square. Okay, let's do the length of AC. So the length of AC would be the square root of, what do we say, 4 and 7? 4 squared plus 7 squared. Okay, because we're just going to use the rise over the run to do the same thing. You can use the formulas, and that's fine. But usually this is easier if you have a graph. So that's 16 plus 49. That's 65. So the length of AC and the length of BD, which are the diagonals, are the same. So diagonals congruent. This means that it is a rectangle. If the diagonals are congruent, it's a rectangle. So this is a rectangle. It's a parallelogram, not a rhombus or a square, because the diagonals are not perpendicular, but it is, diagonals are congruent, so it is a rectangle. Okay, number 10. Probably, yeah, I'm gonna have to erase this because I don't really have much room here. And let's actually zoom in a little bit too. Yeah, that's better. Okay. All right. -4. 1, 2, 3, 4. -1. 0, -1. 0, -5. 2, 3, 4, 5. -4, -6. 1, 2, 3, 4, 5, 6. That looks odd. Okay, you can kind of tell by looking at this that it's not even a parallelogram, but let's just go ahead and show. So first we need to show if it's a parallelogram or not. So we have to show that two sides are both parallel and congruent. So I'm going to do the slope of EF and the length of EF. Then I'm going to do, that's it. HG. Slope of HG and the length of HG. Okay, so the slope of EF is actually 0 because you have no rise. So EF has a slope of 0. HG has a slope of up 1 and then 1, 2, 3, 4 over 4. So 1 over 4. Okay. The slopes are not the same. Or sorry, my mistake. I'm doing, let me get rid of this. Sorry, I put it in the wrong place. That's the length of EF. I was doing the slope of HG, so 1 over 4. The slopes are not the same. In order for this to be a parallelogram, the slopes have to be the same and the lengths have to be the same for one pair of sides. The slopes are not even the same, so this is not a parallelogram. This is just a quadrilateral. We don't have to check anything else because all the other ones are parallelogram. The answer key says that this is a trapezoid. EF is horizontal. Yeah, okay, technically this is a trapezoid. So, oh yeah, we do need to include our test for the trapezoid. So why is this a trapezoid? Well, we have to test the other two sides as well. So if this has one pair of parallel sides, then it's a trapezoid. So these sides are not parallel, they're not congruent. So this is not a parallelogram. But if we go to the other sides, the other pair of sides, this side and this side, these sides are parallel. Okay, they both have an undefined slope. The slope of EH and the slope of FG, they're both undefined because they don't have any run. They're both vertical. So undefined, undefined. But you can tell from the picture that they both have the same slope. So these are parallel. So what you have is you have one pair of parallel sides. And by definition, that is a trapezoid. One pair of parallel sides is a trapezoid. Let's check to make sure we got the other one correct. That was a rectangle, right? Yeah, rectangle. Okay, explain why this parallelogram is not a rhombus. Okay, that's easy enough. Let's see, 2, negative 2. 1, 2, 3, 4, 5, negative 1. 5, negative 5. 1, 2, okay, 1, 2, 3, 4, 5. 5, negative 5. 2, negative 6. 1, 2, 3, 4, 5, 6. Okay, so explain why this is not a rhombus. Well, I would just check the diagonals and see if the diagonals are perpendicular. You can check all the sides and see if all the sides have the same length, or you could just check the sides next to each other to see if they have the same length because we already know that this is a parallelogram. So we don't have to check that this is a parallelogram. We already know that. Okay, so let's get the slope of MK. That's the diagonal. So up 1, 2, 3, 4, 5 over 1, 2, 3. 2, 3, 4, 5. 1, 1, 2, 3. Okay. This is why sometimes it can be easier to use the slope formula. So slope formula y2 minus y1 over x2 minus x1, because I'm having a hard time seeing my graph. This can also be a reason that you might want to use the distance formula as well. Distance formula, y2 minus y1 squared plus x2 minus x1 squared. Okay, so if you're having a hard time seeing the graph and doing it on the graph, just use the formulas as well. Okay, so slope of the other diagonal, which is JL, okay. Okay, so what is the slope of this? So 1, 2, 3, so 3, negative 3. So 1, 2, 3, and then 1, 2, 3. Okay, so the slope of this is negative 1. Negative 1, 5/3. These are not perpendicular. They're not opposite reciprocals. Diagonals are not perpendicular. Not a rhombus. The diagonals have to be perpendicular for this to be a rhombus. Likewise, you could have checked that the sides are congruent. What did she do? Yeah, she did the diagonals as well. Okay, and that is it for the review. Alrighty, I'm gonna end the video because it's already kind of long. Good luck, everybody.